Today I'm going to show you why this Radio Shack 22-305 is a lot better than you remembered it is. This is a really awesome frequency counter. This frequency counter came out in 1994. I purchased my example when they first came out, this one right here. And they sold for $99.99. It's really been an awesome frequency counter, although I don't use it as much as I used to, because I've got a myriad of frequency counters. I've got more than I probably should. Before we get into playing with this frequency counter, and we will be opening this device up, I have never opened it up. I have never seen inside this device until I saw an internet photo today, and we'll be poking and prodding around in there and taking a peek at it. Before we do so, a little technical mumbo jumbo on it. It has two gate speeds. It has a fast at 64 milliseconds and it has a slow at 640 milliseconds. Right now you're watching the slow. As you can see, it is just that, pathetically slow. And there's the fast. This frequency counter was designed by Tandy Electronics Design and was implemented using a 4th cross compiler for a Samsung 4-bit microcontroller, which I believe is the same as a Commodore C64 computer. Now the credits on this, the electronic design is by a fellow by the name of Doug Deeds and Jerry Heap. Firmware design was also done by Doug Deeds, and the mechanical design was done by Morris Humphrey. Now this frequency counter is also sold abroad, however not under the Radio Shack brand. You will find this as a Revex FC200 and the Revex FC200 II. The difference between those two is the FC200 is identical to this outside of its name silk screened on here, as well as extra silk screening up here on top. The FC2000 II, second revision, is just like it with the exception of this switch right here. As you see, this one here is marked with a toggle switch on the far right with a below 50 and a above 50. The FC2000 revision 2 has a third switch on the left, which marks it from 0 to 10 megahertz, which you can see here in the photograph on your screen. Now, what information I was able to find was the 0 to 10 megahertz is actually for TTL operation. As you can see here in this photo that I have on your screen, it's a poor quality photo, true, but it's the only one I could find. In fact, I was unsuccessful in finding a service manual or a owner's manual for the SC2000 revision 1 or revision 2. If by chance you have such documentation, by all means, I'd be very much interested in obtaining a copy. I also have desire in purchasing a FC2000 revision 1 or revision 2, but that may be a long wait, as I'm not sure how often they pop up, as I just found out about its existence just prepping for this video past a couple of days ago. The frequency specs on this states that it covers from 1 megahertz to 1.3 gigahertz. However, in this video we'll see that this frequency counter far exceeds that, and that's why you must own this frequency counter. It is a awesome frequency counter, and they only sell for around $30 to maybe $50 on eBay. I would keep trolling if you're in no big hurry to ascertain one. Just keep waiting until you find it at your price point, and then you too, like me, will be fat and happy. And what makes this frequency counter rather exciting and unique is the fact that it uses a MB 506 Prescaler, and as you can see here on your screen, the Prescaler has a maximum high frequency range of 2.4 gigahertz. And so how this works is when you're at frequencies above 50 megahertz, the Prescaler kicks in and uses its amplifiers as such to get the higher frequencies. It also uses the same Prescaler to derive at the lower frequencies, except for at which time it's not using its amplifiers. And let's go ahead and get the show on the road, shall we? As you see, we have the frequency counter turned on. And this is where the fun and excitement happens. We're going to see that we will plug it into the frequency RF generator, and we will plug it into coax. Now the coax I'm using is Belden 50 ohm coax. This is old coax I had made back in the 90s. It's not rated at high frequencies, and as you see, we also have BNC connectors, and as we know, BNC connectors are not rated at high frequency neither. I'm not sure where their cutoff point is. However, in this demonstration, I think you'll see that we are going to be fat and happy. So the low end for the frequency counter is 1 meg, and as you see, we have 1 meg punched up here. We have the audio generator turned off, and over here I have the power set to 1 volt continuous wave. Now, for the scope of this video, I'm not going to test the sensitivity. That may be a video or a subject for another time, or it's something that you yourself could do on your own accord. I will say that the owner's manual for this device is fairly close from what I've spotted, and we'll go into a little bit of demoing that as we test this device. But again, this is not scientific, and I'm not going to test it verbatim. We're just playing around to see what the device is capable of doing as far as counting frequencies. Now I'm going to go ahead and turn up the power on this, and I'm going to go all the way. And so now if we come down here and we see that we have indeed 1 megahertz. And if we switch over to the gate speed, you can see that it does change decimal point. The owner's manual also states that there's going to be a lull between, I believe it was 50 and 54 megahertz. I find that that actually is not the case. And you'll also notate that this frequency counter sports a 50 ohm and a high Z impedance switch. So that'll help out in your testing as well. So as you see, we very comfortably have a 54 megahertz frequency as well as a 50 megahertz frequency. I find that the calibration of my device is pretty well spot on. So I'm very happy with its accuracy for its age and for the fact that I have never calibrated it, but then again, I've never abused it and thrown it about. Mine is still in pretty good condition. And then the high end is 1.3 gigs. And to access the 1.3 gig spectrum, we just flip the switch over. So now we have 1.3 gigs. And we have about 0.8 watts in there. So that is very exciting, 1.3 gigahertz. Now we're going to play a little bit here. I'm not going to be able to show you both devices in one shot, as you can tell that this video is being shot handheld. So hopefully we won't get too motion sickness by me making the adjustments here. Fairly clearly that's above the 1.3 spectrum that it says. And I just turned down the RF a little bit. Let's just go ahead and go to 0.4 volts. Let me keep spinning. So as you clearly see, we are definitely exceeding the manufacturer's printed documentation on this, or specs. Now it's kind of interesting to note that the 2 starts to flicker once we get up in the high frequencies. I'm not sure exactly what that's about. Could be something to deal with the registries or whatnot. But by all means, we are there. Let me turn up the RF power a little bit. Now you see the frequency counter has stabilized, and we had lost the 2 as we are at 0.6 volts. And here I had to turn the power up some more. Let's just go ahead and set it at 1 volt. The highest that I've actually been able to get this to read stabilized is at 2.47 gigahertz. And as you can see here, the tail end is not locked in, not quite as stable. And as I was mentioning earlier about the feed line, the coax, it's 50 ohm. It's not designed for these high frequencies. as well as the BNC connector. And then I've got this coupling right here. Again, we go from PL259er to SO239 to PL259 down to this UHF connector here. Well, it's not UHF, it's N connector. So we do have some loss burnt up, but it is a short run of coax. Let's push our luck just a little bit here. And as you see, it's unstable. I could turn this up just a little bit more. However, that did not help it any. If I had more power, probably better proper feed line and proper ends like SMA connectors or something, I could probably, probably achieve the higher frequency. But again, as stated, the device is only good for 2.4. The Prescaler is only good for 2.4 gigahertz, and we were able to get 2.47 out of it. So I think that's pretty good. For the low end, as I stated, it's good for 1 megahertz. And for the next test, turn my RF down on that. For my next test, we're going to go to my function generator, and we're just going to work with sine wave and not RF, although I can do RF, but in my testing I find that it really didn't make any difference. Ignore that frequency, as I was just playing around. So we'll go ahead and put this at 1 meg, and we'll put the power at 1 volt peak to peak. We are 50 ohm out, and I do not have it terminated. And for that, we need to, oh, we're there. Now we'll go back up to here, and we'll toggle this to that position. We'll drop it down to 500 hertz, and as you see, we're at 500 hertz. So we definitely exceeded the specs on the device. Now the lowest that I've actually was able to get this to read was at 190 kilohertz. As you see, we lost it there at 100. So if I go back to 190 kilohertz, and the highest power you could put into this is 1.4 volts peak to peak. However, there is an exclusion to that number. I found that if we go via TTL, and we're using the same coax, now on TTL, I found that we can actually go to 150 kilohertz. Okay. Well, that's making a liar out of me. On my device, I'm unable to control my RF power on TTL. So let me change this cursor position. Oh, okay. So here we are at 166 kilohertz. So that appears to be about as low as at this testing point that I'm able to get it to semi-stabilize. In my earlier test, I was able to get 150 kilohertz. Thing must be having a bad day. And to show that yes, indeed, we do have a TTL signal. So with that said, let's go ahead and open this up. Since I am using a portable handheld camera, I will not be able to open this up on screen. But I think all we need to do is remove these 4 screws, pull out the batteries, which I don't really think matters, but we'll pull them out anyway. And we should be in like Flynn. I have the back plate removed, and it's a really nice piece of metal. Now I need to tear apart the board from the case, and I believe all I have is these 2 screws right here, and then that 1 screw right there, and that should come apart. Okay, got it completely tore apart. Got the face of it, and this is the main board. And that chip right there is the microcontroller. It is a 4-bit Samsung KS56C220. See if I can get it closer. There we go. So that is the brains of the operation. And the power source on this, battery wise, you could use standard AA batteries, alkalines, or you can put rechargeables in here, and that's what this switch is. It'll switch between AA and rechargeables. I'm using rechargeables. And of course you have a power jack right there, which (9 volts). And then on top we have the BNC connector. And then on the face we have the display. There's our 4 meg crystal. And I'm not sure what that is. And I believe that green pot is to calibrate our 4 meg crystal, and we're actually going to check that out to see if indeed how close we are to spec. And I guess I should clean those switches while I got it tore apart, and I'll clean those ground connections there as well. In my model, the backlight is failing. It's getting really weak. So at another point in time when I'm feeling gumptious, I will try to replace it. You'll have to tear that metal bracket off and remove the LCD screen and put a new light in behind it. Trying to see if I could locate the Prescaler. Oop. Lost my switch. Might as well take them all off. And I guess since I'm this far, I might as well put a little cleaner in the switches and take care of that, although I'm not having any issues with them, but I got it tore apart. Alright, so now let me go ahead and put batteries back into this. The service manual wants the 4 meg crystal to be set to 3.999996 to or through 4.Z all the way up to .4. I am slightly off. So let's see if I can really make it a whole bunch off. Or should I have just left well enough alone? Well, I'm slightly high. I'll try to back it down just a hair. I think I'm going to leave it there. That's a lot better than what it was. So I'm pretty happy. So with that happiness, let's go ahead and see about putting in a frequency. Yeah. I'm going to tempt fate, see if I can adjust that just a hair better. I think that's better. I think I'll leave it right there. So we got our 1 gig in, and let's go with perfect. Earlier during disassembly of this, I was wondering where our Prescaler was. Well, it's right here. That right there is our Prescaler. Went ahead and deoxed the switches. And I cleaned up my grounding contacts. And to clean the contacts, I used my fiberglass brush that I bought from Radio Shack, probably, about the same time, give or take, whenever these came out. Good brush, I recommend them. I just had to replace the tips on them. You could buy these and the replacement cartridges on eBay. So let me go ahead and wipe down the screen and put it together. So there's a whole host of reasons why you would like to own this frequency counter. It's an awesome frequency counter, kind of easy to service, well, calibrate anyway. and definitely does exceed the manufacturer's specs. And for a few pounds, a few shillings, it too could be yours. Alright, that will conclude this video. Thanks for watching. As always, I definitely do appreciate it. Subscribe, comment, and like if you haven't already. And remember, free videos always. Be good humans. Take care. Bye.